Hi guys, this is an introductory lecture for the COMP09022 Data Comms and Networks module for 2024. So I'm Duncan Thompson, I'm the module coordinator. This is just a kind of quick overview of what's in the module, some background information about how it's going to run and so on. So firstly what I want to do is just give an overview of how the module is going to work, how it's going to be delivered, how it's going to be assessed, where you can find resources for it and so on. Then I'd like to talk just briefly about some of the numerical work and some of the mathematics stuff you need to know to succeed in this module. Don't worry, there'll be lots of hand holding going forward, but this is just a wee heads up at the start. And then finally, just a very quick revision of the OSI 7-layer model and an overview of the module, the 10 topics we're going to cover over the course of this term. So I'm going to start out just by, as I said, an overview of the module, how it's going to be delivered, what the learning outcomes are, how it's assessed, what to look at, where to look for your feedback, a wee bit on engagement and resources. So I'll just go through these things in order. So as I said, I'm the module coordinator. My name's Duncan Thompson. On Paisley campus you can find me in E370. That is no longer, well, it is my direct dial number, but I no longer have a telephone on my desk, so the best way to get me is email, or if you see me on Teams, you can catch me on Teams as well. I'm not logged onto Teams every day, but email I will read every day. There are two deliveries of this module. I deliver the UWS one on Paisley campus, and it's also delivered at New College Lanarkshire, where Charlie Johnson does the delivery. That's his contact details for NCL students if you need to get in touch with him. Normal weekly timetable, and here I'm kind of talking about Paisley, so things might be slightly different at NCL. We will have nominally 1.5 hours of lecture, which will normally be between 1 and 1.5 hours, and then we'll move into 1.5 hours of tutorial. That's only part of the story. If you've read the module descriptor, you will know that there's 200 notional hours, so 3 hours a week for 10 weeks is only 30 hours, so there's obviously quite a lot of other time that you'll need to put in to succeed in this module, around about 10 hours a week, or a bit more potentially. This year, basically in previous years, or 2 years ago, we had recordings of lectures as of last year, and that will continue this year. I will be delivering lectures firstly, so please do attend the lectures before you come to the tutorial. There are video recordings of lectures from 2022, but I don't yet have them on a streaming server because that's one of the things that's not yet back up after the cyber attack. I will be trying to make 2020 MP3 recordings of this year's lectures and uploading them to Moodle. They're too big for Aula, unfortunately, but I should be able to put them on Aula, on Moodle, so you should be able to find them there. But in general, the delivery for Paisley campus is 9 till 10:30 we'll be in F307 for the lecture, and then from 10:30 to 12 we'll be in D124. Now that may, the length of the lecture will probably vary from week to week. I think some of the shorter ones are probably closer to the hour mark, whereas some of the longer ones are probably a touch over an hour and a half, but it will be in that ballpark, yeah. And after we've done, we'll take a break, and then we'll meet in the tutorial room about 10 minutes later. For New College Lanarkshire, ask Charlie. Hopefully Charlie will be letting you know when your classes are and where you should be. These are the learning outcomes of the module, so these are straight from the module descriptor. Demonstrate a critical understanding of the design of network protocols, demonstrate a detailed knowledge of an area of data communications, and use numerical and graphical methods to analyse network performance. You're also going to have chances to develop other skills in this module, so research skills, writing skills, working in teams as well. These all form part of things you'll be doing for some of the assessments. Speaking of assessments, there are basically 3 assessments for the module, split into 2 categories. 50% of the module's marks are for coursework. There are 2 courseworks. One of them is due in around about halfway through term. It's an individual research-based report. It will be appearing on Aula shortly, if it's not already there by the time you read this. It's worth 20%, and then there is a group-based report which will come out round about the time the first one's due in, and it will be due in at the end of term. I'll be assigning groups randomly after after, or more or less when the first coursework is due in. If you haven't been attending classes, you will find that you are not assigned to a group. So unless you tell me that there's a good reason you've not been in classes and that you want to be assigned to a group. The other 50% of the marks for the module are on the exam. It will take place in week 15, and I will be giving you more information about that in due course. There are past papers available on Aula, so you can take a look at them and see how they look. There won't be a massive change in terms of content and format this year. To pass the module, as normal for UWES modules, you will need to get at least 40% overall for the module, and you'll need to get at least 30% in each category. So by category, that means in the coursework category and in the exam category. So that means that it is possible to do badly in one coursework, but to make up for that in the other coursework. It's also possible, to do badly in the exam as long as you don't get less than 30%, provided your coursework then brings you up to the pass mark overall. Obviously, your third year modules potentially are counting towards your honours classification, so you're probably aiming for more than just a pass, but that's what you need to pass the module. From your assessment and from other places, you'll get feedback. Feedback comes in various different forms. It's important for you as students to know what's feedback. So, if I'm halfway through a lecture and you ask me a question and I answer it, that's feedback. If you ask questions on the Aula feed and you get an answer, again, that's feedback. But probably what you're more used to is feedback on your assessments. So for your summative assessments, your two courseworks, you'll get a grade, which is a form of feedback, but you should also get comments on your summative assessments, which are really there to help you improve future submissions, future work that you might do in this module or in other modules going forward. There's also a number of formative assessments, so you'll find on Aula and Moodle that there will be a range of quizzes that you can do to test your knowledge. They don't count towards your final mark, that's why they're called formative assessments. They're designed to help you identify what you're good at, identify your weaknesses and be able to work in them, and so on. There are multi-choice questions for all topics, so you'll find there's a 10-question quiz for each topic on Aula, and you should also find as the module moves forward that there will be further quizzes on Moodle. I previously had calculation-based questions for pretty much all the topics where there were calculations. These have been lost in the cyber attack. I'm going to be trying to restore these as we move forward on a kind of week-by-week basis. And there was also a bigger bank of multi-choice questions as well on Moodle, so I'll be trying to reinstate that and give you access to it as well. You'll also get general feedback on your exam. You'll get access to past papers and feedback that went with them. So do use that as we come close to the exam and you start studying for it. You're welcome to ask questions on the Aula feed. I will try to answer any questions you ask there. If it's a general question about the module, I'd rather you ask there rather than an email, because if you ask an email, what I'll probably do is put it on the Aula feed anyway. Only use email if it's a personal question that is something specific to you. Yeah. The other thing you'll find on Aula and on Moodle are previous MEQs. MEQ stands for Module Experience Questionnaires. You will be asked about your experience on this module towards the end of the module. I use these responses to improve the module and change the module as time goes on. So please do fill that in when you're asked to towards the end of term. But you'll also find previous ones on Aula and Moodle, and you'll find changes which have been made. For example, I've made changes to how I deliver the module. I've made changes to how I assess and the timetables of assessment and so on, based on student comments in the past. So if there are things that are going well or going badly in this module, things that you'd like to see in other modules, let me know. If there's things you think need changed, let me know that as well. That's the place to do that. In terms of engagement, as normal for UWS, you're expected to engage with this module. That basically means I expect you to attend and participate in classes. Normally I take attendance about halfway through the tutorial. I may also take attendance in the lecture this year. I'll see. Last year I just took it in the tutorial. I might take it in both this year. I'll see how things go. You're also expected to take part in all summative assessments, so in other words, the assessments which count towards your final mark. And I would encourage you to take part in other things as well, so formative assessments, discussion forums, things like that. The more you engage with the module and its materials, the better you'll do in general. If you are not engaging with your studies, so if you're not attending and you're not handing in, for example, the first coursework, what will probably happen is that you will be withdrawn from the module. If you don't engage with the assessments, then you won't get a resit. You'll be expected to come back to the module next year and do the whole thing again. So please do engage with both the classes and the assessments. Finally, in terms of resources, basically two places where you'll find things for this module. Aula is the kind of primary source at the moment. That's the URL for Aula. Aula has copies of all the slides, copies of all the tutorials. I will be trying to give out paper copies of the tutorials in the classes, but you'll find them online as well. As I go forward, I'll be making MP3 recordings of my lectures, so I'll try and upload them to Aula or possibly Moodle, because I don't think Aula has space for them. Once I have a place to put them, I'll put the pre-recorded videos I have from a couple of years ago. There's a module feed on Aula. There are formative assessments, as I said, multi-choice per topic, but also there'll be calculation quizzes going up on Moodle as I rewrite them. You'll find past papers and feedback. You'll find another useful thing, which is preparatory revision material for the maths, which we cover in the module, which I'll talk about in a moment. And there used to be quizzes to go with that on Moodle. Again, they've disappeared with the cyber attack, so unfortunately they're not there. The preparatory materials are, however. The things on this slide which are marked with an asterisk have gone missing because of the cyber attack. I will be trying to reinstate as many of them as I can over the course of the term, but some of them I just probably won't get round to doing. So probably, for example, the maths quizzes I won't get round to doing. Hopefully the calculation quizzes for the module material itself I will, and as soon as I have a place to put the videos, I'll put them there as well. Okay, the second thing I want to talk about in this introductory lecture is a little bit on numeracy and maths. So you may remember, those of you who are new to third year this year, you may remember there was a maths induction at the start of term. Primarily that is there because this module is probably the main place you're going to come across maths and calculation work in the degree. So here I just want to very quickly go over again the things you need to know to succeed in this module. As I said, there'll be lots of hand holding in the tutorials. You'll probably find the first few tutorials are quite hard going if you haven't done maths for a while. I'm here to help you. Charlie's there to help you. Please ask us for help. Ask us if you get stuck in things. Don't struggle with a calculation when you can just ask for a bit of help and hopefully get used to doing these calculations. Having said that, the stuff you need to know are scientific notation units and SI prefixes, a wee bit about how to work with scientific calculators, how to work with formula, how to use formula, how to change the subject of formula, and a wee bit on logarithms. The last two of these, I guess I would count as maths. The first two are more advanced numeracy. So let me just quickly go through what these things cover. So scientific notation, with this module we're going to be working with very big and very small numbers. So things like the speed of light, the frequencies of microwaves, wavelengths of light waves, particularly times taken to transmit data or times taken for a signal to transfer across a medium. If we write out these numbers longhand, it takes time. It's also quite error prone because it's very easy to leave out a zero, miscount the number of zeros between the decimal point and the significant digits, for example. What scientific notation lets us do is it lets us express these kinds of numbers as a product of two other numbers, one of which is called a coefficient or a significand. It's the one that's got the significant figures of the number. And the other one is a power of 10. It's normally known as the exponent. It's positive for large numbers and negative for small numbers. For small numbers, I mean numbers much less than 1, between 0 and 1. A couple of examples down the bottom there. 3 times 10 to the 8, that's the speed of light in meters per second. So 3,000,000,000 is how we would write it out in longhand. 3 times 10 to the 8 gives us a much quicker and less error prone way of writing it. 1.5 times 10 to the minus 6, that is a very small number. It's 1.5 millionths, so that might be, for example, the time it takes a signal to cross a medium. 0.00000015 seconds, for example. Excuse me. Again, scientific notation lets us express that more quickly and with less room for making mistakes. Many numbers that we work with are associated with a unit telling us what it is we're measuring. So that might be a distance, it might be a time, it might be a frequency, a power, amount of data, it could be all kinds of things. If we are expressing these things, if we're giving a numerical answer to a calculation and there's a unit should be there, then you should state the unit. There will be a mark for the unit in the exam. Certainly for the last answer in an exam, there'll be a mark for the unit. If you leave it out, you'll be missing out on that mark. So get used to using the right units. Meters for length, seconds for time, hertz for frequency, and so on. If it's a ratio, so sometimes it's a number called a ratio, which is how much bigger than some other number is. They can be stated without a unit. And you may also come across SI prefixes being used for some units. So for example, you may come across things like milliseconds, microseconds, being thousandths and millionths of a second respectively, or you might come across things like kilohertz, megahertz, gigahertz, meaning thousands, millions, or thousand millions of a hertz respectively. So get used to working with them. There's more on that in the materials on Aula. You may also come across IEC binary prefixes, kibi, maybe, and gibi. They are the numbers close to 1,000, which are powers of 2. So 1024 is a kibi. A kibi byte, for example, is 1024 bytes, and maybe byte is 1024 times 1024 bytes. I don't know that number off the top of my head, but basically 2 to the power 20. Yeah. So they're particularly used for quantities of data. You'll see them used. You won't generally see them used for other things. You will require to use a scientific calculator for this module. So hopefully you already have one. Please bring it to class. It should be non-programmable. If we end up going back to in-person exams, you're not allowed to use mobile phones in the exam, so you are better using a scientific calculator. In general, scientific calculators do a better job of what they do than mobile phone applications do. So I would encourage you to get hold of a scientific calculator now, work with it for the next few months, so that when you get to the exam you're familiar with how it works and what it can do. Things you need to know about your scientific calculator: it can display numbers in scientific notation, and generally will if they're very large or very small. It can also accept numbers in scientific notation. There will be a special button to allow you to do that. Make sure you know what it is and use it when appropriate. It will use mathematical precedence rules. In other words, it will do powers before multiplication and division, and it will do multiplication and division before addition and subtraction. It follows the general rules in maths for what order we do these kinds of things. It will allow you to use brackets to do things in different orders if you want. It might give you exact answers for calculations. So if you say 1 divided by 3, it might tell you that the answer is 1 divided by 3, which is maybe not what you're looking for. Maybe what you're looking for is 0.33333, for example. Make sure you know how to get it to display in decimal form if that's what you're looking for. Again, there'll be a button to swap back and forward between decimal and exact form. It will have memories, so usually most mathematical calculators, scientific calculators these days, have multiple memories. They can be very useful if you're doing a long complicated calculation and you want to use one of the early results later on in a different calculation. Learn how to use the memories and how you can do that. It will also have a number of mathematical functions, some of which we'll be using, so things like logarithms, for example, which I'll talk about shortly. It may also support other number bases like binary and hexadecimal and be able to convert back and forward. We wouldn't really be using that in this module, but it might be useful for other modules. If you haven't got a scientific calculator, you're absolutely welcome to ask for advice on buying one. The main thing you want to look for is a logarithm to any base button, which I'll talk about briefly in a couple of slides. The other thing you'll be doing in this module is you will be working with formula. So we'll be doing calculations where you have a formula, an equation that basically says the thing on the left hand side is equal to this combination of things on the right hand side. There'll be some algebraic combination of variables on the right hand side which is equal to the thing we're trying to calculate. Usually the thing we're trying to calculate is on the left hand side and the combination of information we know is on the right. Calculating the result in that case is just knowing how to put that right hand side into your calculator correctly. Sometimes you might need to change the subject of a formula, so maybe you want to calculate one of the things that's mixed up with everything else on the right hand side of the equation. In that case you can use elementary algebra to change the subject of a formula. To do that, basically you need to know a couple of things. You need to know that an equation can be changed as long as you do the same thing to both sides of it. So you can repeatedly apply basic algebraic operations to both sides of an equation and it still is true. So if you add x to both sides, the equation is still true. If you multiply both sides by a, the equation is still true. So the reason you might want to do that is in order to move something from one side of the equation to the other. Let's say some value is multiplying something on one side. If we know that the opposite of multiplying is dividing, we can divide both sides of the equation by that thing, and that means it disappears from the right hand side of the equation and appears on the left hand side as well. So what you need to know in order to do that is you need to know that addition is the opposite of subtraction, division is the opposite of multiplication, raising to a power of such and to a power of 2, for example, is like taking the nth root. So raising to the power of 2 is like taking is the opposite of taking a square root. Raising to the power of 3 is like raising to the power of 1 over 3 or taking the cube root, and so on. And raising a number to the power of something, the opposite of that is taking a logarithm. So I mentioned the L word a couple of times, so I just want to finish this section by talking briefly about what logarithms are. We'll use logarithms in quite a few places in this module. We'll be using them straight away in the first week. So the first week of proper material, not this introductory lecture. Logarithms are basically the opposite of raising a specific number, which we call the base, to the power of something else. So, for example, if we have a base b and we are raising it to the power x, and we know that y is b to the power x, that is the equivalent of saying that x, this number here, is the base b logarithm of the number y. Yeah. So this is the equivalent of this. Yeah, but this one here is using a logarithm operation. B is called the base of the logarithm. We can use logarithms to lots of different bases. You will probably find that your calculator has two bases built into it. It will have base 10 logarithms, which will usually be labelled log on your calculator. We'll be using them in topic 2, I think, is when we first come across base 10 logarithms. And we'll also be using the other kind of logarithms which are on your calculator called natural logarithms or base E logarithms. We'll probably be using them in week or topic 5 or 6, I can't remember exactly. It's usually labelled as an ln on your calculator. In actual fact, we'll probably not use that button itself, we'll use the inverse of the ln button, the e to the power x button. We'll talk about that when we get to it, don't stress about it just now. The other thing you want to have on your calculator is a log to anything button. It will look like this, yeah. Generally it will look something like that on your calculator. It allows you to calculate logs to any base. And the reason we want to do that is because the other kind of logarithms which we will be calculating are base 2 logarithms. And normally you will not have a base 2 logarithm button on your calculator, but if you have a log to base anything button, you can specify 2 as the base that you want to use, and that then allows you to calculate base 2 logarithms of whatever you want to do. We'll be doing that in topic 1, the very first topic we cover. If you have a scientific calculator that doesn't have that button, it's not the end of the world. You can calculate base 2 logarithms using your calculator. It's just a wee bit more complicated. So if you can get hold of a calculator that has that button, please do that. Okay, that's really all I want to say about numeracy and maths. The only other thing I really want to finish off with now is a very quick revision of the OSI 7-layer model, a wee word on protocols and what they are and where they come from, and then we'll finish off with an overview of the whole module and the topics we're going to cover. So the OSI 7-layer model hopefully is not a new thing to any of you. You'll have hopefully come across this before. Your third year networking students, whether you've done that in college or in first and second year of uni, you will have seen this before. It includes it's developed by ISO. They've developed a 7-layer model which starts at the bottom, the physical layer, which defines things like voltages, frequencies, how we represent signals on a medium. And we then go up through the data link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer. And up at the application layer, we have protocols which support specific applications. So, for example, functionality for email, or functionality for web browsing, or functionality for file transfer, or whatever it happens to be. The OSI 7-layer model was developed in the kind of late 1970s and early 1980s. At the same time, the internet was being developed, so the internet model is slightly different. It still has a layered model, but it looks slightly different, but it matches up pretty well with the 7-layer model. It's just that in some cases we call the layers different things. So somewhat confusingly, the bottom layer is called the network layer, and it covers layers 1 and 2 of the OSI model. The inter-network layer is pretty much a one-for-one equivalent of layer 3. The host-to-host layer is pretty much a one-for-one equivalent of the transport layer. And then what the internet model calls the application layer really subsumes all the functionality of these top 3 layers in the OSI stack. Similarly, the IEEE, for example, they have been developing a range of different LAN standards. LAN standards, by their nature, tend to work down in layers 1 and 2, the physical and data link layer. So what the IEEE discovered when they were developing protocols is that they wanted to split out some of that functionality into slightly more finely grained layers. So you may come across some of these layers, logical link sublayer and medium access layer, as sublayers of the data link layer, and the physical medium dependent, physical medium attachment, and physical coding sublayers, which are effectively all subsumed into the OSI physical layer module, physical layer. In general, when I talk about layer 1, 2, 3, 4, 5, 6, 7, I will always be referring to this reference model. Yeah, I won't usually talk about the internet model or the IEEE model, but occasionally I'll talk about them and things that go on in there. But this is the model we use as our reference model. So when people talk about layers 1 to 7, that's what they're talking about. It gives us a common framework to work around. Protocols are basically rules for communication. That's their traditional meaning in the real world, and as if networking wasn't the real world, but also that's what they do in computer networks as well. They specify things like when we communicate, how we communicate, what we communicate, and as long as both sides of an interaction are using the same protocol and agree on these things, how they're doing it, what they're communicating, when they're communicating, as long as they're speaking the same protocol, they will be able to communicate with each other. Within or between two peer layers, what we generally talk about is exchanging things called protocol data units, or PDUs. You'll hear me talking about PDUs a lot. Sometimes in specific layers we call these other things. So for example, at layer 2 we generally call PDUs frames. So you'll have heard people talking about Ethernet frames or Wi-Fi frames or Bluetooth frames. They are PDUs at layer 2. You'll certainly have heard people talking about packets. They are layer 3 PDUs, so IP packets, for example, or IPv6 packets. They are the PDUs which are exchanged between IP layers on the two sides of a communication. The protocols themselves are designed and documented by various standards bodies. And which standards bodies does that depends a wee bit on which type of protocol it is. For example, for internet protocols, very often it's the Internet Engineering Task Force who defines them. So they have defined and standardised things like TCP, IP, UDP, DNS, all these protocols which underlie how the internet works. HTTP, which the web is based on, SMTP, which allows you to send email, and so on. They're all defined, standardised, designed by the IETF, and you'll find these protocols online. The IEEE, which I mentioned earlier, the Institute of Electronic and Electrical Engineers, they have defined and designed protocols like Ethernet. They defined protocols like Wi-Fi, like Bluetooth. So again, you'll find the documents which define these protocols on the IEEE standards website. And the ITU, they are concerned more with wide area networking standards. So as you may guess from their name, their background is more in telecoms. So if anyone here remembers modems, all the modem standards, things like V34, V34 BIS, all the rest of them, that's ITU that defines these standards. They've defined a range of standards along these lines as well as other ones. The standards, for example, that your mobile phone uses are ITU, or very often ITU standards. That's pretty much all I want to say about protocols. The last thing I want to cover really is just a very quick overview of how this module works. This is week 1. This is the introductory week. This is these slides. This is the introduction. Next week, the first in-class session will be going straight into topic 1. Topic 1 is on information redundancy and compression. Then we'll look at network media, then we'll look at bandwidth, noise and capacity, then we'll talk about encoding and modulation, and then we'll talk about error control. These are all quite focused on kind of layers 1 and 2. Error control may be starting to come out into layer 3 sometimes a wee bit. So that's going to be the first 5 weeks. Quite a lot of calculation work over these weeks, so we're quite front loaded in terms of where all the calculation sits. Week 7, you will by that time be well deserving of a break from me. Coursework 1 will be due in the very start of week 8, so you'll have no classes in week 7, and you'll be able to work on that coursework. If you haven't already finished it at that point, you'll have a week with no classes. Then week 8, we will carry on with topic 6, which is media access, addressing and path determination, redundancy and availability, quality of service and queuing, and security, and that is the end of our topics. Somewhere in there, towards the end, I think we have spring break. I can't remember exactly where it sits. I think it's maybe between topics 9 and 10, or it might even be after topic 10. I will check. You'll know. I'll let you know in advance. Don't worry, you'll know when that's going to happen. The second coursework will be due in week 13, and in week 14 we will have a revision session prior to the exam, and then the exam will take place in week 15. So that's just a quick overview of how the module is going to run. Hopefully that makes everything clear in terms of when things are going to happen and what we're going to cover. If you have any questions about any of this, please post them in the Aula feed. I'll be posting a welcome message there shortly. So if you have any questions, please do let me know there. And do feel free to introduce yourself there as well. Okay, so just a quick summary of what I've talked about. Quick overview of the lecture, of the module itself, how it's going to be delivered, how it's going to be assessed, where to find resources for it. A very quick overview of some mathematical skills you'll need in order to succeed with this module, so scientific notation, calculators, algebra, logarithms, and then we finished off with just a quick review of the 7-layer model and protocols, and an overview of what's in the modules. I hope that's been useful for you, and that it kind of sets the scene for the next couple of months as we work through the module.